Stop spamming APIs. Most front-end applications don't break because the back-end is slow. They break because front-end events fire too often. This is Data Handling and UX, where we explain front-end concepts using real production problems, not definitions. Today's topic is debouncing versus throttling. And this is one of those topics interviewers love because it reveals whether you've actually built real apps. The real problem. Let's start with something simple. Open any search bar. Every time you press a key, an event fires. Type fast, and you might trigger 10 to 20 events per second. Now imagine calling an API on every keystroke. You're not building a feature anymore, you're spamming your back end. And this problem isn't limited to search. The same thing happens with scroll events, resize events, mouse movement, infinite scroll, analytics tracking. Events don't fire once, they fire constantly. This is where real performance problems begin. Why this breaks real applications. When events aren't controlled, three things usually happen. First, API calls explode. You send requests for intermediate states the user doesn't even care about. Second, duplicate requests pile up. Older requests return after newer ones and overwrite fresh data. Third, rate limits get hit. Features suddenly stop working, not because of logic bugs, but because traffic gets out of control. This is exactly why debouncing and throttling exist. Debouncing, how real apps use it. Let's talk about debouncing. Debouncing is used when only the final action matters. Think about a search input. When users type, they don't care about results after every character. They care about results after they stop typing. Debouncing works by waiting for a short pause. If the user stops typing for, say, 300 milliseconds, you send one API request. That's why debouncing is used in search inputs, autocomplete filters, form validation, and type-ahead suggestions. Without debouncing, APIs get spammed, backend costs increase, UI flickers, results feel unstable. With debouncing, one clean request, predictable UX, controlled backend load. The key idea is simple. Debouncing waits for silence. Throttling, how real apps use it. Now let's talk about throttling. Throttling solves a different problem. Some events never stop firing. Scroll events fire continuously. Resize events fire continuously. Mouse move fires continuously. Waiting for them to stop doesn't make sense. Throttling limits how often your logic runs. For example, once every 100 milliseconds, once every 200 milliseconds. No matter how often the event fires, your code runs at a controlled frequency. That's why throttling is used in infinite scroll, scroll listeners, resize handlers, animations, and analytics tracking. Without throttling, scrolling becomes janky, layout recalculations explode, CPU usage spikes, and UI becomes unresponsive. With throttling, smooth scrolling, predictable updates, stable performance. The key idea here is throttling allows continuous updates, but at a controlled rate. Real production mistakes, senior level. In real production apps, the mistakes are more subtle. The first mistake is debouncing too late. Developers debounce the API call, but they still update component state on every keystroke. So even though the backend is protected, the UI still re-renders constantly and feels slow. The second mistake is debouncing at the wrong layer. Instead of debouncing the event itself, the debounce logic lives inside the API service. Now multiple components can still trigger events, and the behavior becomes hard to reason about. The third mistake is forgetting request cancellation. Debounced or throttled API calls still return promises. If an older request resolves after a newer one, the UI can display stale data. That's why real applications cancel previous requests or ignore outdated responses. The fourth mistake is recreating debounced or throttled functions on every render. In component-based frameworks, if the function isn't memoized, it gets recreated on each render, and debouncing silently stops working. Everything looks correct, but the backend still gets spammed. These are the bugs that pass code review and only appear under real user load. Most debouncing problems aren't about timing, they're about where and how the logic is applied. The senior decision rule. Here's the rule experienced front-end engineers use. If the final result matters, debounce. If continuous feedback matters, throttle. Search, debounce. Filters, debounce. Scroll, throttle. Resize, throttle. Always ask, what does the user expect? When does feedback matter? What is the cost of delay? Debouncing and throttling are UX decisions, not utilities. Interview plus production bridge. In interviews, definitions are easy, but interviewers really want to know what breaks in production, why APIs get spammed, why UIs feel laggy, how you control event frequency. Senior front-end engineers don't memorize debouncing and throttling, they design event flow. Next topic in this series, your app feels slow. Memoization in real front-end applications. And if you want the interview questions for debouncing versus throttling from beginner to senior level, comment questions and I'll share them.